Okay, sir. Thank you, sir. Once again, good evening to everyone. Welcome you, Ramakrishna, sir. Myself, K. Sujata, Assistant Professor from EEE Department. It's my pleasure to introduce Dr. Pothuraju Ramakrishna, sir. Sir has received BTech degree in Electrical and Electronics Engineering from JNTU Anantapur in 2014 and received the MTech degree from NIT Kurukshetra in 2018 from Electrical Engineering Department with Power Electronics and Drives specialization. Also, he received his PhD degree from Electrical Engineering Department, NIT Tadepalligudem in 2023. Present, Sir is working as an assistant professor in the Department of Electrical Engineering at Dr. B.R. Ambedkar National Institute of Technology, Jalandhar, Punjab. Sir's research interests include power electronics and drives, electrical machines, multi-level inverters, and renewable energy sources. Sir has published more than 20 articles in reputed international journals and IEEE conferences. Thank you. Thank you, one and all. Once again, welcome you, sir.
Thank you, madam.
Okay, sir.
So
thank
now
you.
I request hand over this session to Dr. P. Ramakrishna, sir.
Yeah. Thank you, sir. Am I audible, sir?
Audible, sir.
Yeah. First of all, I would like to thank Sujata madam for giving brief introduction about myself. Am I audible?
Okay,
No?
sir. Thank you, sir.
Okay, sir.
Yes, sir.
Audible, sir.
Yeah. Yeah. Okay. So, very good evening to all of you. Myself, Dr. Pothuraju Ramakrishna, working as an assistant professor in the Department of Electrical Engineering at Dr. B.R. Ambedkar National Institute of Technology, Jalandhar, Punjab. So, first of all, I would like to thank the organizing team for giving this opportunity to deliver a guest lecture in this Atal-sponsored online faculty development program on artificial intelligence applications in renewable energy sources. Also, I would like to thank Anil sir for giving this opportunity. So now I will share my presentation so that I will continue session.
Thank you, sir. Accepting our request for your busy schedule.
Yes, sir. Thank you, sir. Is it visible, sir?
Okay, sir.
Yeah, okay. Thank you. So once again, good evening to all of you. So in this session, mainly I would like to concentrate on to give you a brief introduction about the renewable energy sources. I want to discuss about the working of the hydroelectric power plant. In this one, to install the hydroelectric power plant, what is the selection criteria? Also, I will discuss regarding the what are the advantages and disadvantages of hydroelectric power plant, and also will discuss what is the need of automation in hydroelectric power plant, what is the need of integration of hydroelectric power plant with grid. With this grid integrated application, what is the need of electric vehicles, what is its important, and also I would like to discuss regarding multi-level inverter fed PMSM drives, their simulation results under different operating conditions and hardware results. I want to discuss solar powered PMSM drives also. So when coming to introduction, nowadays power generation using renewable energy sources become more popular and challenging task due to deficits of fossil fuel sources in coming future. So that we can't depend on the fossil fuel for the power generation in coming future. So that we need to put more concentration generation of power by using renewable energy sources like hydropower, solar power, wind power, biogas, biomass, fuel cell waste. So in this regard, if you take the what is the power generation capacity in India as on date, if you take as on 30/11/2023 from Central Electric Authority, this is the total power generation is around the 426 gigawatts. In this 426 gigawatts, the power shared by the fossil fuel is 56.1%, that is around 240 gigawatts. The remaining power shared in the total power generation is by the non-fossil fuels, like that is renewable energy sources. That power is about around the 43.9%. So in this 43.9%, what is the contribution of the hydropower? The hydropower contribution is around 11%. Wind, solar, and other renewable energy sources is around the 31.1%. So here the significant contribution is done by using the hydropower plant. So it will place a key role in the total power shared in the total generation capacity. At right now, the present installed capacity as on date is around the 454.5 gigawatt. So that the share of power generation by using renewable energy sources is increasing day by day. From the starting onwards, 1980 to 1985, now it is around the 43%. So like that, the power generation by using renewable energy sources is increasing day by day. So renewable energy sources plays a very key role in generation of the electricity. So if you take the layout of the hydroelectric power plant, we know what is the basic principle of hydroelectric power plant, how it will generate the electricity. So by conversion of potential energy of water stored at some head is converted into the electrical energy by using turbine. So the potential energy of the water is converted to the electrical energy through using the turbines. If you see this layout of hydroelectric power plant, as we know that it consists of the reservoir, dam, penstock, turbine, and powerhouse. In powerhouse, we are having the turbine, generator, transformer setup. The power generated from the alternator is transmitted to the nearby grid by using the transformer. Okay, so how it will work? So whatever water is storage at the reservoir, that is used to send to the turbine through the penstock. So it will create the high pressure of water. This high pressure water is flowing through penstock pipes to the turbine, so that we can control the force pressure of the water that strike the blades of the turbine, so that it will create the kinetic energy at the turbine. This kinetic energy is converted to electrical energy, because here generator is coupled to the turbine. So what is the purpose of generator? Generator will convert the mechanical energy to the electrical energy according to the Faraday's laws. So whenever you are keeping some if there is a rate of change in the flux cutting in a conductor, it will create the energy, electricity. That is the principle of generator. So from the generator, we can generate the electricity by taking mechanical input from the turbine shaft, because generator and turbine both are mechanically coupled. So whatever power is generated from the alternator is at the 11 kV in general in India at 50 hertz frequency. So anyway, our loads are located at far away from the generating station. So the generated power is going to be transmitted over the transmission lines. Before going to be transmitted the power, we need to step up the voltage, generated voltage, because the generated voltage at 11 kV, that we should step up to the higher kV, because to transmit the constant power over the long time, if you increase the voltage, what will happen? Power equal to V equal to I, so that V increases, I reduces, so that the value of current is going to be reduces by keeping power constant, so that I square losses, the losses in the transmission system can be reduced over the transmission for a long distance. So by keeping this mind, we are step up the voltage at the generating station. So this is the working principle of the hydroelectric power plant in brief. So as I told, these are the main components. It consists of the water source. Water source includes rivers, dams, and reservoirs. So these are constructed in order to store the water such that we will get some potential energy of the water. And we are using penstock. The purpose of penstock is to transmit the water from the dam to the powerhouse where turbine is located. The purpose of turbine is to convert the kinetic energy of water into the mechanical energy. So as this turbine is mechanically coupled to generator, the mechanical energy is going to be converted to the electrical energy by using this generator. Here we are using some control valves. We need to control the flow of water input to the turbine by using this control valve, so that we can regulate the output power generated from the generator. So as per our requirement, we can control the flow of water to the turbine by using this control valve. And governor system is used to control the speed of the turbine for the optimal operation, so that it will play a key role in maintaining the speed of the turbine as per the optimal operation. And as I told, transformers are used to step up or step down the voltage as per the requirement. At the generating stations, these are used to step up the voltage. At the distribution side, these can be stepped down to as per our local industrial and household appliances. And also it consists of this on switchgear and protection system. The purpose of switchgear and protection system is used to ensure the safe operation by disconnecting the faulty component. So with this protection system, we can identify the, is there any faults in the system, is there any over current, over voltage, any other fault, temperature rises, so that we can make certain control algorithm to disconnect this faulty session from the healthy session. So it is regarding the brief introduction about the working of the hydropower plants. So now, when coming to the classification of hydroelectric power plant, depends upon availability of water. It is classified like a runoff river plants, reservoir plants, pumped storage plants. What is runoff river plants? Runoff river plants will use the natural flow of rivers. In the canals are like this. So there is no separate dam is constructed for the storage of water in case of runoff river plants. So we can generate the power during this rainy season or any flood seasons only. In case of reservoir plants, in order to store the water, we need to construct some reservoir dam, so that we can store the water, so that as per our requirement, we can take water from the reservoir through the penstock to the turbine, so that we can generate the required power. So that is the advantage of the reservoir plant. When coming to pumped storage plant, in addition to reservoir, in this pumped storage plant, we will construct one more tank for the storage of water, so that we can pump the water from the bottom to top. It depends upon the power demand. In case of the low power demand, we can up the water from the downside to the storage plant. In case of high demand power, we can use the whatever water is available at this temporary storage. So that this is the classification based on availability of water and construction of dams, and depends upon the power capacity. So depends upon what is the generating power capacity of the power plant. It is classified like a pico hydro power plant. Like if power is less than 5 kilowatt, we can say pico hydro power plant. If it is less than 100 kilowatts, we can say micro hydel power plant. From 100 kilowatts to 1000 kilowatts, we can say mini hydel power plant. From 1 megawatt to 50 megawatt, we can say small hydel power plant. If power generation of power plant is from 50 megawatt to the 1000 megawatts, we can say it is the large hydel power plant. So, and I have given the required applications. So these rating of power plants are used for corresponding power plant. For example, if you take large hydel power plant, it is used in large cities to supply the power for the large cities. In case of small hydel power plant, we can use for the small cities to town. So like that, depends upon power capacity, we can use to the certain applications. Now, before going to construct any hydro power plant, we should take the proper plan. We should take the proper planning to select the site. So this includes the, like you need to select the site such that there is a availability of water. If there is no water, we can't run the hydroelectric power plant. So that we need to search the area such that where water availability is more, where abundant water will be available, such that we need to select the site. One more thing is topography, means we need to select the site such that it is very favorable to construct the dam or reservoirs so that it will support the infrastructure of the hydroelectric power plant, such that that place should help in creation of the high potential head of the water so that we can easily generate the power. And also we need to consider some environmental impact. It means that we need to make some environmental assessment must be conducted to evaluate the potential impact on local ecosystems or water quality or wildlife so that we can minimize the disruption to natural habitat, and ensuring the sustainable water is crucial. So that we need to consider these parameters. Also, whatever site you are selected for installation of hydropower plant, it should be somewhat nearer to the large load center so that we can reduce the cost of the transmission. So you need to select the site that is somewhat nearer to the large load centers. Also, the selected site should be geologically stable. Means we need to select this site such that it is very stable to avoid the risk of landslides or earthquakes or erosion. And also whatever rock and soil structure of the site, it should support the construction of dams and other structural elements. So while selecting the site, the site should be supporting the construction of the dam. Also, it should overtake the risk of the landslides and the earthquakes. Also, we need to consider some regulatory and social considerations. It means that we need to follow the local regulations, government policies, and community acceptance are important factors. We need to consider all these things so that we need to meet the all legal requirements, including water rights, land acquisition, and social impact to ensure the smooth operation and execution of the power plant for the long-term sustainability. So you need to consider all these parameters for the perfect installation of any hydropower plant. Now we will see some advantages and disadvantages of hydroelectric power plant. Because hydropower plant means we are generating the power by using the potential energy of the water. It will become under the renewable energy source so that there is no cost of the fuel. It is natural resources. Okay. Also, the operating cost, because it is the cost free, so that the operating cost of hydropower plant is very low when compared to the other power plant. Also, the efficiency of the hydropower plant is high when compared to others. It is around the above the 90%. And as the water is available, we can supply the power throughout the day. Depends upon the water availability in the storage. So that we can say the hydropower plant is the reliable and stable power supply it can generate. And also it is used to control the flood control and water supply, because as we are constructing the reservoirs for the storage of water during high flood seasons, we can control the flood control by protection of the water storage. Because it is flexible and quick response, means we can generate the power from the hydropower plant as per our required power demand by controlling the water flow input to the turbine, because we have the control over the water input to the turbine. So as per our requirement, we can control the water flow such that we can control mechanical energy, so that we can control the generated output power from the generator from the hydropower plant. When coming to even though it has advantages, it has some disadvantages also, because the initial cost of hydropower plant construction is very high, because it involves the capital investments for the infrastructure, construction of dams, reservoirs, turbine. All these includes the financial challenging issue. So the initial cost is very high for hydropower plant. Also environmental impact, because we can't expect the rainfall throughout the year. There is a depends upon the seasonal also, so that it is somewhat environmental dependence also. Also we can't locate this hydropower plant in all places. It depends upon the location also. Location dependency means we need to select the site that is nearer to some hill area so that we can reduce the cost of the construction of dam in all sides. So if we have the hill areas, only one side dam is sufficient, so that we can reduce the uh, investment cost. And also this hydropower plant is vulnerable to the drought. So during the reduced rainfall and drought condition, it will generate the reduced power because it depends upon the water. Also, due to the sedimentation problem, it requires the proper maintenance. So it will create the additional cost, and also this sedimentation problem in the reservoir may leads to the effect of the lifespan of the plant. So it requires the proper maintenance. Also, it will take the long time for the construction of the dam initially. So all these things are the some of the disadvantages of hydropower plant. Now we will see what is the need of automation in hydroelectric power plant. Why we are going for automation in hydropower plant? So the main reason why we are going for automation in hydroelectric power plant means because the main objective is to maximize the efficiency of the plant by optimizing the water flow and the turbine operation. So you need to optimize the water flow input to the turbine, and you need to optimize the turbine operation so that you can generate the required power from the power plant as per the load demand. According to load demand, you need to use the power input so that you can generate the required power. Also, to enhance the safety by monitoring critical parameters like a pressure, temperature, flow. So we need to always monitor these critical parameters in order to make sure the safety operation of the power plant. So all these things can be monitored by using this automation. Also, by using this automation, we can reduce the manpower so that we can reduce the potential error. Human errors we can reduce by reduction of these human inventions. Also, by using this proper automation, we can integrate this hydroelectric power plant with the grid so that we can give the safety and reliability power supply to the consumers which are connected to the grid. So automation plays a key role in interconnection of the hydro power plant with the grid. This automation involves the different control systems like a PLCs, program logic controllers, SCADA system, supervisory control and data acquisition system. In some large systems, it will use some distributed control systems to monitor and control the plant operation. So the main purpose of this automation is to monitor and control the plant operation. So we need to monitor some critical parameters so that we can operate the plant with safety conditions. So this is need of the automation in hydroelectric power plant. So as I told, this automation in hydroelectric power plant involves use of SCADA system, PLC and the DCS. SCADA system is nothing but supervisory control and data acquisition system. The main purpose is it has the lot of sensors so that it will collect the all real-time data from various parts of the power plant, and also it will provide the operators to monitor the plant parameters remotely so that the operators who are sitting at the plant, they can monitor the present data from the different parts of the hydropower plant so that it will facilitate the control over the turbine, gates and the valve. So it will create some inputs to control the turbine flow input and the valves by using PLC program logic controller. So the main purpose of PLC is used to control the equipment like a turbine, valves and the gate. So with the help of the available real-time data which is available from the SCADA system, we need to write some programs with respect to the reference quantities so that we need to as per our required demand, we need to turn on the signals to the valves and the turbine and gates, so that we can properly provide the sufficient input to turbine, so that we will get the required power output from the power plant. In case of the large or complex power plant, we can use the distributed control system. It means that it will offers the centralized control for continuous monitoring and adjustment of the plant process. So where we can have the individual subsystem control, everything can be converted into a single system, so that centralized monitor can be done by using distributed control system. So this is the one of the example, and it shows the how SCADA system is helping to control the turbine input. So this SCADA system, it will monitor all the present real-time data. It will calculate the present load demand on the system. According to load demand, it will give the control signal to the turbine, so that turbine will regulate the output power by controlling the input flow of water. So if you take any power plant, it may have a number of generating units, so that for each and every generating units, it will provide the control signal by using the PLC system. So this SCADA system will provide the real-time data across all equipment in the power plant, and also it will provide the data required load demand on the system. So according to this, we need to generate the signals for the operation of the turbine, so that we will get the optimized power from the turbine, or so that we are getting the required power generation from the hydropower plant, which is sufficient to satisfy the load demand. Now we will see what are the some control strategies and main features of automation. So the main feature of automation is to provide the proper flow control. Means we need to give the proper flow of water control to the turbine, so that we can regulate the output as per the demand. Also, it will provide adaptive control and feedback control system. It means that we need to... Hello, is there any doubt? Automation system use the closed loop feedback control system, such that it will adjust the turbine speed and water flow to match the load condition. In some cases, if there is any water flow changes in the reservoir also, it will respond quickly. Also, the automation will take care of the turbine and generator synchronization. It means that as we are mechanically coupled the generator and turbine, these two should be run at the synchronization. So the same thing also take care by this automation system. This automation also help in the load frequency control. The load frequency control is the one of the main problem in electrical power system. So it means that due to grid integration, due to variation on the load demand, there is a change in the voltage and the frequency of the grid. So that we need to manage. That can be done by using this automation. So it will check the what is the present output power, what is the demand. According to this one, it will give the control over the governing system, so that it will generate the exact power from the turbine alternator. Also, it will maintain the constant frequency. This automation system also provide the automatic start and stop system, so that it will reduce the use of the manual power. So as I told, load frequency control is one of the crucial aspect of power system. The main purpose of load frequency control is always to make the power generation is equal to the load demand. If there is any deviation from the generation and the demand on the load on the grid, there is a changes in the supply frequency and voltage. We need to always make sure the voltage and the frequency constant, so that this load frequency control will help in maintaining the system frequency constant. Also, it will help in balancing the supply and the load. Also, it will optimize the generation, so that it will control the input according to required output. This automation, as I told, as we are using SCADA system, it consists of the lot of sensors and transducers, because we need to measure the electrical quantities by using electrical sensors, mechanical quantities by using transducers, because transducer is used to measure the mechanical parameters in terms of the electrical, so that we can easily implement the control signal, data logging and remote monitoring. So by proper collection of the real-time data, we can monitor the data and we can store the data. The stored data is used to implement the control algorithm. This automation system also provides safety and protection system. Means, as we are having the lot of sensors, we can identify what is the present data at each and every aspect, so that we can monitor whether these available data, is there any uh, over, like if is there any mismatch in the present data and the rated capacity. For example, we can identify over current, over voltage, under voltage. It leads to the malfunctioning of the system. So that by using these sensors, we can estimate the present real-time data, so that we can operate the all equipments within their rated limit. If is there any deviation, we will get some errors, so that we can give some alarms and notification. Also, in under some emergency situation, we can shut down the plant also, such that this automation system will provide the all type of information regarding any errors. It will give through alarm notifications. Also, it has the generate signal such that to shut down the entire power plant also, if is there any severe case, so that it will provide the safety and protection to the entire power plant by using this automation system. Also, efficiency optimization. So by using this automation with proper monitoring present data and the demand, we need to control the input to the turbine, so that we can optimize the turbine operation, which leads to the energy management across the load and the supply. Also, it will provide some predictive maintenance. It means that it will collect, depends upon the present data, it will identify that is there any equipment is going to be repaired, so that it will identify the when it is maintenance is required for particular component in the plant, depends upon their operating data, so that it will provide the predictive maintenance to the different parts in the power plants also. With proper automation means we are controlling the exact frequency and the voltage at the output as per the required power, which leads to the integration with the smart grid system. So if you are able to control the output power and frequency and voltage, now you are ready to connect your power plant to the grid. If your power plant data, output and grid both will mismatch, there is a problem. So we need to always match the grid and the power plant by using this automation. So we need to collect the information regarding load. So according to that load, we need to optimize the operation of the power plant such that it will generate the required power supply to the load. So the integration with grid system is possible with suitable automation in the hydropower plant. Again, there are some challenges. It is not that much easy to implement complete automation in hydroelectric power plant. There are many challenges and future directions to implement the automation in hydroelectric power plant. For correct data monitoring, we need to go for some advanced control techniques like artificial intelligence, machine learning, IoT based for real-time monitoring, which help in the exact implementation of the grid stability. So these are the some of the challenges. So hydroelectric power plant automation plays a crucial role in improving the operational efficiency, safety and reliability through the grid integration. Because through grid integration only we can supply the reliable power supply to the all loads. If there is no integration, grid integration with one power plant, it is very difficult to satisfy the load always. There may be a chance of load increasing or decreasing. That can be taken care by using this grid integration. So we need to properly control the present load demand. According to that, we need to operate these renewable energy sources along with the thermal power plant or nuclear power plant. So always we need to use the in maximum extent renewable energy sources in order to reduce the greenhouse gases to the environmental. Because if you use thermal power plant or nuclear power plant, there is a huge environmental pollution. So maximum time we need to depend upon the renewable energy sources. So in this grid integration, this SCADA system, PLC, DCSR plays a crucial role for optimizing the power plant and to supply the electricity to the all loads. So with proper automation of hydroelectric power plant, we can integrate the hydro power plant to the grid. So this is the picture. It is showing that all different types of power plants are connected to the grid. So here nuclear power plant, thermal power plant, hydro power plant, solar, wind. So like fossil and non-fossil, all power plants are connected to the grid and different loads are also connected. So that depends upon the load condition, we need to optimize the operation of either hydro power plant or solar power plant or this wind power plant, all these renewable energy sources, because wind and solar power plants are intermittent, because continuously we can't get power from the wind and solar in a day, but depends upon the water availability, continuously we can get the power from the hydraulic power. So all these renewable energy sources will assist the this fossil power plant in reducing the power generated by using fossil power plant, because always we need to supply the load by using these renewable energy sources so that we can reduce the dependency of the fossil fuels, so that we can save the environmental pollution. Because in coming future we can't get these fossil fuels for a longer time, so that government is taking lot of initiatives to generate the power by using thermal wind power plant and solar and the hydro power plant. So now need of integration of hydroelectric power plant into the electrical grid. Why we are going for integration of different renewable energy sources? In that renewable energy sources, hydroelectric power plant also one. So what is the main reason? So as I told, we are going for integration only to provide the reliable and stable power supply to the consumers. Because if you depends on only one power plant, we can't supply the power to the load continuously. So in order to enhance the reliable and stable power supply to the consumers, different power plants we need to integrate to each other, so that these renewable energy power plants can assist the fossil power plant like a thermal power plant and nuclear power plant. Because anyway we are having the automation in this power plant, so that as per required load demand we can control the power output from the individual power plants like a hydro power plant or solar or wind. So one of the advantage with integration is renewable energy integration. So as I told, by going for this renewable energy integration means we are integrating all renewable energy sources like a solar, wind and hydro. By doing like this, we are the dependency on the thermal power plant, nuclear power plant can be reduced, so that we can reduce the carbon emission into the environmental. Okay, so that's why we are getting the low carbon emissions with renewable energy integration. Also, we can provide the energy storage, efficient load management and flexibility. It means that for example, if you take a hydro power plant, there is a chance of storage. In case of pumped storage power plant, you can store the additional water so that you can increase the reliability of the hydro power plant. So like that we can support the grid. During the peak demand we can use this stored power. During the low power demand we can use the reservoir water. So according to the load requirement we can use the input. Similarly, we are getting some economic benefits also with grid integration, because cost effective generation, as we are integrating renewable energy sources to the grid, the cost of fuel is reduces, so that it will become the cost effective. Also, in order to supply the continuity of power supply to the consumers, it will impact on the per unit cost, so that hydropower plant plays a key role in the market. Also, this hydropower plant will support the other renewable energy sources like wind and the solar, because wind and solar power will not available continuously in the day. So that renewable energy power will assist these renewable energy sources along with the non-renewable energy source power generation. So that this renewable energy sources integration will create some environmental and social consideration. It means that the renewable energy source integration will reduce the fossil fuel dependency. So as I told, if you are generating required power by the demand from the renewable energy sources, so that we can reduce the dependency on the fossil fuel based power plant like thermal and nuclear, so that we can reduce the environmental pollution, so that the operating cost also will be reduced. So all these are the advantages with the grid connection of the renewable energy sources. Again, as I told, everything has some challenges. So it is not that much easy to integrate the power plant. So there is some challenging task, like there is a different factors it will affect the grid integration. Hydrological variability depends upon water availability, seasons, environmental conditions. Sometimes we need to update the grid infrastructure as per the availability of the water levels in the reservoirs. So that all these things will affect the will create some challenges in the grid integration. So with this, I would like to say grid integration of hydroelectric power is essential for ensuring stable, flexible and sustainable electric system, so that it will support the renewable energy, other renewable energy sources along with the fossil based power plant. Also, it has several benefits such as reliable power generation, support for renewable energy integration. It also providing the energy storage, also economic advantages like a cost effective power generation. As I told, it has some challenges. It should also, we need to manage while integrating the renewable energy sources with the grid, like such as environmental consideration and also some grid infrastructure development. All these things are the challenges while integration of renewable energy sources with the grid. So this is regarding the importance of automation in hydroelectric power plant. With proper automation in hydroelectric power plant, we can give the stable, safety and protected power supply to the consumers. In grid, nowadays electric vehicles become the more popular over the conventional vehicles, because it has a lot of advantages, because we are using the electric supply instead of the petrol, so that we can reduce the fuel dependency. It will reduce the environmental pollution, so that we are getting the better environment condition, as it reducing the noise pollution, so that the life cycle of the vehicle also very more, and efficiency also more for the electric vehicles over the conventional vehicles. So as I told, this electrical vehicle plays a key role in reduction of carbon dioxide emissions into the environmental, so that we can reduce the greenhouse gas emissions, so that we can reduce the no carbon emissions by using the renewable energy sources. So nowadays, renewable energy based electric vehicles also become more popular, like a solar powered based electric vehicles. We can construct the solar panels on the roof of the vehicle, so that the generated power can be used to drive the vehicle. So in case of electric vehicles, the main part is the drive system. Drive means the system used for the control of the motion. So in electric vehicle, main key part is the electric drive. Electric drive is nothing but the system used to control the motion of the system by using electrical machines. We can say it is the electric drive. For example, if you are using some mechanical engine, diesel engine, petrol engine, to control the motion, we can say it is the mechanical drive. Instead of mechanical engine, if you use some electrical motor for the control of the motion, we can say it is the electric drive. So I want to discuss, this is my PhD research area. So I want to give brief about these things. Basically, all of you know that this electrical drive system has the structure like this: source, power modulator, motor, load, sensing unit, and control unit. The source is nothing but available single phase or three phase source. The power modulator purpose is from the available source, it will generate the required power to the motor. If motor is AC motor, power modulator has the rectifier, so that AC to DC, so that DC power is given to motor. For example, motor is AC motor, power modulator act like a inverter. Inverter will convert the DC to AC, so that the required power to AC motor is given by the inverter. So that the power modulator will consist of the different power electronic converters like a rectifier, voltage regulators, inverter. So depends upon the availability of the motor, either AC or DC motor, this power modulator will convert the available supply to the required power supply to the motor. And we can connect the load to the motor. We are using some sensing unit. The purpose of sensing unit is like to sense the voltage, currents, and the torque and speed. These things are used while implementing the closed loop technique. So according to our required demand, required speed and power demand, we need to give the control pulses to the power electronic circuit that is available in the power modulator. Because in power modulator, we may have the rectifier or inverter. So for that one, we need to give the control switching pulses. That can be done by using some control unit. With respect to input command means reference commands and measured parameters, we need to design some control technique. By using that control technique, we need to give the switching pulses to power modulator, so that power modulator will give the required power supply to the motor according to our requirement. So this is the working of any electric drive system. So as I told, the electrical drives has the more advantages over the mechanical drive system, because here we are not using any fuel, so that fuel cost is less. Environmental pollution also will be reduced. As we are using electric motors, we have the lot of speed control techniques in electric motors. 4-quadrant operation is possible. Regenerative braking is also possible. The efficiency of electric motor is very high when compared to the mechanical machines. So that all these are the somewhat advantages over the mechanical drive system. Now, when in case of drive, the main thing is the motor. Motor will drive the wheels of the vehicle. So what type of motors we are using? So the motor classification is classified like AC motor and DC motor, depends upon the input supply. If you are using DC supply, we can say DC motor. If you are using AC supply, we can say AC motor. In AC motors, we are having the depends upon the stator rotor speed. We can say it is the synchronous motor, asynchronous motor. In synchronous motor, both stator and rotor will rotate at the same speed. In case of asynchronous motor, example induction motor, the rotor speed is always less than the stator, so that there is a slip speed will be exist. So like that, among these all these motors, nowadays permanent magnet synchronous motors become more popular, because these permanent magnet synchronous motors have the different advantages over the DC motors and the induction motors. In olden days, they are using DC motors for the traction purpose, but there are a lot of disadvantages in DC motors, like a noise. These DC motors are using brushes maintenance is required. There is a problem of commutation failure in DC motor in the winding. So if proper commutation is not take place, there is a short circuit, burning of the winding, which leads to the damage of the motor. So all these drawbacks in DC motors are overcome by going to the induction motors, because similar to DC motor speed control, we are having the speed control technique in induction motor also. So from DC motor to induction motor is era is shifted. Again in induction motors there are some losses like a high starting current. It has the both stator and rotor winding, so that copper losses are more, efficiency is less, and also dynamic performance also poor in induction motor. So to overcome these drawbacks, now we are shifting towards the permanent magnet motors, PMSM. Because in permanent magnet synchronous motors, we are not using any rotor winding, only we are using permanent magnets on the rotor core, so that we are reducing the rotor winding, so that we are reducing the losses in the winding, so that the efficiency of PMSM motor is more when compared to induction motor. Also it has the high power density, high torque density, high torque to weight ratio. All these advantages of PMSM makes me to choose PMSM motor is sufficient for the electric vehicle applications. So these are the some of the advantages of PMSM over the DC motors and the induction motors. Nowadays research is going on PMSM motors. In addition to PMSM, we are using some SRM also, switch reluctance motor. In PMSM, we are using permanent magnets on the rotor core. In case of the switch reluctance motors, these permanent magnets are eliminated, so that there is a somewhat advantages with respect to PMSM in SRM. Now one more thing is, in case of drives, the speed control plays a crucial role, because we need to control the speed by using this different speed control technique. Under different speed control technique, it is classified like a scalar control and vector control. In scalar control, we have the V by F control. In V by F control, we need to make the V by F ratio constant, such that we can avoid the problem of magnetic saturation in the core. So in order to overcome this drawback, we are going for vector control. The vector control is classified like a field oriented control under the direct self control, DSC. In direct self control, we are having the direct arc control, direct arc flux control with space vector modulation, SVM, and model predictive control. In field oriented control, we are having the direct field oriented control, indirect field oriented control. So depends upon the how we are calculating the rotor position. Field oriented control is classified like a DFOC and IFOC. In direct field oriented control, rotor position is calculated by using the rotor flux and the rotor D and Q component fluxes. In case of indirect field oriented control, rotor position is found out by using slip speed. In case of direct self control, direct arc control is the one of the method. I will compare FOC, DTC and DTC SVM. Next slide. See here. In case of field oriented control, the drawback is we are controlling the flux and torque indirectly by controlling the current components. It is a not direct control method. In case of direct arc control, we can control the torque and flux directly, so that it is the one of the advantages over the field oriented control. But in direct arc control, we are using some hysteresis controllers, which leads to the variable switching frequency in direct arc control, which leads to the high torque and flux ripples. In case of electric drive, main thing we need to consider low torque and flux ripples. If flux and torque ripples are more, it will leads to the more vibrations and noise in the system, so that it will reduce the lifespan of the system. So that always we need to implement the speed control technique such that the torque and flux ripple should be very low. In case of direct arc control, due to use of hysteresis torque and flux control, the ripples are more due to variable switching frequency. In order to overcome the variable switching frequency in direct arc control, we are moving towards the DTFC SVM. Means we are adding the space vector modulation technique in addition to the direct arc control, so that we can maintain the constant switching frequency, so that we can reduce the low torque and flux ripples. So that I am implementing the direct arc and flux control along with space vector modulation to the PMSM drive. I will discuss some of the speed control techniques in the next slides. For example, if you take the field oriented control, if you see here, we are taking the current. So this system is consist of the inverter. Inverter is used to drive the PMS motor. We are using some speed sensor to estimate the rotor position in PMSM. By using rotor position, we are converting the ABC currents of the three-phase parameters to the two-phase currents like a D and Q component, so that we are controlling the Q and D axis current. So flux is controlled by controlling D current, and torque is controlled by controlling the Q axis control. So it is done indirectly. In case of field oriented control, we are controlling the torque and flux indirectly. Torque is controlled by controlling IQ, flux is controlled by controlling ID. It is indirect control. Also, it is using more number of Clark and Park transformations. So that it is the one of the drawback in field oriented control when coming to direct torque control. As I told, in direct torque control, the structure is same. Here we are controlling the torque and flux directly by estimating the torque and flux by using motor parameters like a VDS, VQS, IDS, IQS. So by using the motor parameters, we are estimating the torque and flux of the motor, so that we are controlling the torque and flux directly. In case of field oriented control, we are controlling indirectly by controlling the current components. And here it consists of the flux controller, torque controller. These flux and torque controllers provide the error in stator flux dψ and the dTe. It will provide the change in flux and change in error. So according to this change in flux and change in error, we are having some lookup table. So for increase in torque, dt is positive means 1, we need to increase the torque. So in different sectors, we need to select the different voltage vectors, so that we can achieve the required torque performance. So that it is the predefined selection table. So as per the torque and flux errors from the hysteresis controllers, this voltage vector selection table will select the one of the voltage vector that is used to drive the switching pulses to the inverter, because the inverter purpose is to convert the DC power to AC according to our requirement. According to our requirement is means we need to give the switching pulses SA, SB, SC to the each phase of the three-phase voltage source inverter. So here voltage vector selection table will generate the one of the voltage vector that is driven to the inverter, so that inverter will generate the required power supply to the motor. So like this, we can control the torque and flux in direct torque control. As I told, the main drawback in direct torque control is, if you see from the voltage selection table, according to torque and flux error, randomly it will select this voltage vectors V0, V1, V2, V3 like this. So it will leads to the variable switching frequency. Because of this reason, it will creates the large flux and torque ripples, so that drive performance will be reduced. So in order to overcome this drawback, now I am going for the direct torque and flux control with space vector modulation. So in this one, we are replacing the flux and torque hysteresis controller with a normal PI flux and torque controller. The output of the flux controller is taken like a voltage components. From the voltage components, we are generating the reference voltage signals to the SVM block. What is the SVM? SVM is the one of the pulse width modulation techniques like a sinusoidal PWM. In case of sinusoidal PWM, we are taking one reference signal and carrier signal, so that we will compare these two, so that we are getting the switching pulses. Okay. But in case of space vector modulation, by taking one reference input voltage, we need to generate the switching pulses SA, SB, SC, so that we can turn on the switches in the inverter as per our requirement. So this is the structure for any closed loop speed control in electric drive. The motor may be changed, either induction motor or PMSM or SRM. The structure is same. so that we can implement all control technique to the all missions. Only difference is their modeling equation. So these are the modeling equations. Modeling equation is nothing but these equations will represent the operation of the PMSM. Voltage equations, flux, like this. Hello, am I audible? The slide is not changing. Yeah, see here. So these are the modeling equations. These are the torque and flux equations of the PMSM, because I have done my research in PMSM motor, so that I am discussing these things. So as we know that this is the basic two-level inverter. In two-level inverter, we are having three legs, means three phases. Each phase is having the two switches, one upper switch and lower switch. These two switches in one leg should operate in a complementary manner, because if S1 and S2 is turning on at the same time, it will short circuit the DC source. So that we need to turn on the S1 and S2 such that complementary manner. Means if S1 is turned on, S2 is turned off. Like that, S3, S4, S5, S6. All these switches are the complementary in nature. So the output of inverter is given to load, where load is the PMSM motor. So as I told, SVM. SVM is the space vector modulation technique. It is the one of the advanced PWM technique to the inverter. In space vector modulation, the total diagram is divided into the total 360 degrees like a hexagon. It is divided into 60 degrees. Each 60 degrees is known as the sector. Like we are getting total sector 1, 2, 3, 4, 5, 6. So in case of two-level inverter, depends upon the switching combination to keep. Means total 8 voltage vectors are possible. V1, V0, V1, V2, V3, V4, V5, V6, V7. In this 8 voltage vectors, 6 are the active voltage vector, V1 to V6. V0 and V7 are the null vectors. It means their magnitude is 0. All these voltage vectors have the magnitude of 2 by 3 VDC. So by implementing this PWM technique, we can generate the switching pulses to the inverter. So if you see all switching pulses for each and every phase in the three-phase inverter. So these are the switching pulses under the sector 1, sector 2, sector 3, sector 4, 5, 6, 7. See here how we are generating the switching pulses means. So from the speed control technique, we are getting reference voltage input. From the reference voltage input, we need to calculate magnitude and angle theta, V reference. So that depends upon theta, we can estimate the where this reference voltage is falling, either sector 1, sector 2, sector 3, 4, 5, 6. So that we can estimate the where this reference voltage vector is falling in this 360 degrees. So according to that, we need to select the nearby 3 voltage vectors in a sequence manner. For example, if it is in sector 1, first we need to select V0, V1, V2, again V7, V1, V2. So like that properly we need to select the voltage vectors. So that we need to implement the reference voltage. Okay. So that we need to generate the reference voltage by using any speed control technique. By using this speed control technique, we will get the reference voltage. According to this reference voltage, we need to generate the switching pulses by using this SVM. So first we need to calculate the dwell times, means how much time V1 switch should be turned on, how much time V2 voltage vector should be turned on. So like that we need to calculate the dwell times. Then according to that, we need to design the switching pulses. While designing the switching pulses, we need to select the voltage vector such that there is only one bit change. One bit change is nothing but so if you take here V1 and V2 1002 110. It means that there is a only one bit change in B position. So like that, we need to select the voltage vectors in a sequence such that there is a only one bit change from one switching state to the another switching state, which causes the low switching losses in the system. So like that, we can design the switching pulses, and these switching pulses can be given to the inverter so that inverter will drive the motor. So in order to get the better advantages, we need to go for multi-level inverters. As we know, in case of two-level inverter, output voltages have the only two levels, so that more harmonics. So in order to get sinusoidal in nature output voltage, we need to go for the multi-level inverters. So multi-level inverters are having the more advantages over the two-level inverters, like a low THD in voltage and currents, low rating switches are required, EMI effect also will be reduced, so that multi-level inverters are preferable for the high power applications. In multi-level inverters, we are having different inverter topologies like a diode clamped inverters, cascade edge bridge inverter, flying capacitor based inverter. In case of diode clamped inverters, the drawback is the capacitor voltage balancing. In case of cascaded edge bridge, we need to require a different DC sources. That is the drawback. In case of flying capacitor based inverter, we need to require the more capacitors. So that is the drawback in flying capacitor. So in general, in electrical drives, we will prefer the diode clamped inverters. Even though it has the drawback of capacitor voltage balancing, we can balance by using this space vector modulation. So if you take 3-level inverter, this is the 3-level inverter. According to different switching patterns, it will generate the 3-level voltage. As number of levels increases in the output voltage, the design of space vector modulation technique also very difficult. So as number of voltage vectors 2 keep means, in case of 3-level, 3 keep means total 27 voltage vectors will be available. So that complexity is very difficult to implement 3-level voltage space vector modulation technique. I am not discussing in depth regarding this PWM technique. It is already published in my journals, so that you can refer these things in my publications. So my thing is here, as the number of levels means, as we are going for higher multi-level inverters, the complexity of generation of the implementation of SVM is difficult. So in case of 3-level, we are getting 3 cube means 27 voltage vectors. So it is very difficult to identify where it is falling and design of switching pulses. So further to improve the performance, we can go for the 5-level inverters also. The structure is same, only we are replacing the SVM here and multi-level inverter. If you take the 5-level inverter, we need to use this 5-level diode clamped inverter. It is the switching table. Depends upon different switching conditions, it will generate the 5 output levels in the voltages, so that the output voltage is more sinusoidal. So in case of 2-level, we are getting total 8 voltage vectors 2 cube. In case of 3-level inverters, we are getting total 27 3 cube. In case of 5-level inverters, we are getting total 125 means 5 cube. So that it is the 5 cube means, if you observe the space vector diagram, the complexity is increased with going for multi-level inverter. Even though there is a complexity, we are getting significant improved performance in the drive. Like that, we are reducing the torque and flux ripples by going to the multi-level inverters. If you see here, now I will show the some simulations results which are showing the improved performance from the 2-level inverter, 3-level inverter and the 5-level inverter. If you see these 3 waveforms, A figure shows the performance of the drive with 2-level inverter, B shows the performance of the inverter with 3-level inverter, C shows the performance with the 5-level inverter. So if we observe these waveforms, we are getting the settling of the speed or improvements in the dynamics, and torque ripples are very low with 5-level inverters. Am I audible, all of you?
Yes, sir.
Yes, here the same drive is simulated under load condition. We are applying load and we are removing the load for 2 level and 3 level, 5 level inverter. If you observe the torque ripples, it is very low with 5 level inverter. So that also we are getting the reduced overshoot and undershoot and under the speed. With 2 level inverters, we are getting around the uh, around 200 100. With 3 level we are getting 57 overshoot. With 5 level we are getting around 23 like this. So like that, my intention is by going for the multi-level inverters, we can improve the performance of the drive operation so that we can reduce the torque and flux ripples so that we are getting the smooth operation of the drive. Similarly, under the different speed conditions, we have simulated my motor so that these are the torque currents and the speed characteristics. So as I told, whenever you are going for multi-level inverters, the voltage waveform will look like a pure sinusoidal so that the THD will be reduces in the 5-level inverters over the 3-level and 2-level inverters. So if you see here, the current THD is 1.6 in 5 level, 3.16 in 3 level, 10.74 in 2 level. Because in 2 level, voltage we have the only 2 levels. In case of 3 level inverter, we are getting the 5, 2n minus 1. In case of 5 level, we are getting the 9 levels. So that the output voltage similarity will be similar to the sinusoidal, so that we are getting reduced ripples, reduced THD also. So these are the comparative results with 2 level, 3 level and inverters. These are the current THDs with under different load. If you observe here, at a higher load, motor will take sinusoidal current so that the THD also will less under the high load conditions. So the same setup can be implemented in a hardware setup so that we are using some reconfigurable inverter that can be operated like a 2 level, 3 level and 5 level inverter by proper managing of the switching pulses, and we are using the PMS motor coupled with the DC generator. In DC generator, we are applying the resistive load indirectly on the PMS, and we are giving the switching pulses to the inverter by using the DSpace controller, DSpace 1104 controller, and we are tracking the speed and torque results by using the DAC pins which are available in the DSpace controller. So we are giving the switching pulses to inverter by using DSpace IO pins, output pins. So this is our laboratory experimental setup. I have simulated same the motor with 2 level, 3 level inverter, and these are the what we are using: controller boards and hall sensors, load torque. This is the how we are interfacing MATLAB and DSpace hardware. So with respect to the simulation results, we are getting the similar kind of the hardware results also. So with 5 level, we are getting the reduced ripples when compared to 2 level and 3 levels. Similarly, under loading condition also, we are applying load at a particular condition. Again, we are removing after some time. So in that condition, during load applied, there is a undershoot of the speed. Whenever load is removed, there is a overshoot at the speed. So these are the torque speed characteristics under the load applying and load removal condition. Similarly, under speed changing condition like a 600, 900, 1200, again we are reducing the reference speed from the 1200, 900 to 600. So at this case, this is the torque and speed performance characteristics. Similarly, we are check the performance of the drive under speed reversal also. From the 1500 RPM to minus 1500 RPM, we are reversing the motor speed by using DSpace controller so that we are getting torque speed characteristic. So these are the currents with 2 level, 3 level and 5 level inverters. You can observe the reduction of harmonic in 5 level inverters. So these are the voltages of 2 level, 3 level and 5 level inverters hardware results. So as I told, capacitor voltage balance is the one of the issue in diode clamped inverter. By using this space vector modulation, I can say with proper selection of voltage vectors, we can reduce this capacitor balance, so that we can get to the all voltages of the capacitors in a all capacitor voltages same, so that there is no deviation, so that there is no circulating currents in the inverter. So here we are getting the experimental and simulation results comparison. And one more thing is here, if you see here, if you see here, all of you, we are using some mechanical speed sensor like a Hall sensor, incremental encoder like this. So the use of speed sensor on the PMS motor shaft, which leads to the additional cost. So proper maintenance is required. So it will leads to some drawback. So in order to overcome this speed sensor, we need to estimate the motor speed by using motor parameters. So that is nothing but the speed sensorless operation. So by measuring the motor parameters, we can estimate the speed of the motor by removing the physical sensor. So that in next step, I have removed the physical sensor and I have estimated the one of the advanced speed control estimation technique like a model reference adaptive system. If you see here, so as I told, multi-level inverter fed MRS based speed sensorless PMSM drive. Sensorless means we are removing the speed physical sensor. In that place, we are estimating the speed. So in order to reduce the system complexity, system cost, we are going for the sensorless control technique, so that the mechanical robustness can be increases, reliability can be increases, maintenance can be reduced, so that inertia of the system is not increased. So with these advantages, we are preferring the speed sensorless control technique. There are different type of speed estimation methods like a observer based method, signal injection, model based. Among these methods, model based methods plays a key role in wide speed range estimation. So that I am selecting the MRAS model reference adaptive system. In this model, see here I am removing the speed sensor. I am using the MRAS speed estimator. It means that by using motor parameters, I am estimating the motor speed, and that speed is taken as the feedback, so that we are reducing the dependence of the speed sensor. So it is the one of the research area. Those who are interested in electrical drive, you can go for the better speed estimation techniques. Also, these conventional PA controllers you can change with a advanced controllers like a ANN, fuzzy logic, machine learning, deep learning, reinforcement learning. Like that, you can replace this conventional PA controller for better performance. Further research is going on a machine learning based this electrical drive. So in model referensive adaptive system, basically we are having the adaptive model, reference model, and adaptive mechanism. From the reference model, we are getting the IDIQ. From the adaptive model, we are estimating the currents. By comparing these two, we are giving to adaptive mechanism. This adaptive mechanism will estimate the speed. So by using these mathematical modeling equations, we can estimate the motor speed, and for that we can derive some transfer function. We can check the stability by using root locus diagram. By observing the poles on left side of the S plane, we can say that the estimated speed technique is more stable. Under different speed change condition, high speed, low speed change condition, we have observed the pole zero plots for this transfer function of the motor estimated speed. So in this case, if you see here, the estimated speed, reference speed, and actual speed all are same, so that our method is accurately estimating the speed. So in second case, speed diagram, we are showing three waveform: reference speed, estimated speed, actual speed. So that the estimated speed is matching the actual speed of the motor, so that it shows the our proposed speed estimation method accurately estimate the motor speed. So here also we have observed the whether our estimated method is accurately estimating the speed or not, so that we are confirming the accuracy of our speed estimation method under 2 level, 3 level, 5 level inverters. The same thing is we are showing in hardware results also. Estimated and actual speed both are same. So as I told, the importance of renewable energy system, nowadays solar powered electric vehicle become more popular due to various advantages as we have discussed. So that instead of giving DC power to the inverter, we can give the power from the solar panels. So that this is the one of the research area you people may can work on this area. By using solar power panel, you can give the required DC to the inverter so that you can optimize the drive performance. So in this case, you can implement some advanced MPPT techniques as a previous session is going on, optimization by using machine learning based MPPT. So whatever you want, new advanced techniques you can implement for the extraction of the maximum power from the solar panels, that you can implement. According to that, you can implement this advanced speed control technique. Everything is same. Only thing is normal DC power supply can be changed with the solar PV array. From solar PV, you collect DC maximum power by using MPPT technique. That power you need to give to the inverter, so that we will get the solar powered electric drive. I think all of you know all these things. What is the solar cell module power panel, like this. So this is the solar cell equation. So you can here we are using P&O technique, perturbed observation method for MPPT extraction. And you can use the distributed MPPT, means for each and every panel you may conduct to MPPT for more reliability. Otherwise, and all panel you can connect it cascaded according to your motor rating. You can implement single MPPT also. So these are the PV and IV curves at different irradiation temperatures. How power and voltage and current will affect with respect to temperature variation and the radiation variation. So similarly, we can get the torque speed characteristics with solar power also. But while designing the solar powered drive, you need to take proper design of DC-DC converters, proper component selection, because according to our motor rating, you need to select the DC power, so that you need to connect the required number of solar panels in series and parallel. To increase the voltage rating, you need to connect the solar panels in a series. To increase the current rating, you need to connect the solar panels in a parallel. So according to your required motor rating, you need to select the proper sizing of the panels. So all these things you need to keep mind while designing the solar power based control technique. So this is regarding need of automation in hydropower plant. With this automation, we can go for the grid integration. One of the grid integration application is electric vehicles, because nowadays research is going on electric vehicles. The use of electric vehicle is lagging due to only charging infrastructure, so that there is a more scope in design of charging stations and impact of charging stations on the grid. So you can go these areas in drives area or chargings or automation. You can go advanced techniques in automation like machine learning based, IoT based, AI based, so that we can implement the advanced automation in hydropower plant, so that it will increase the safety and reliability in power supply to the load demands. So this is from my side, sir. If you have any questions, you can ask any.
Any questions?
Sir, good evening, sir. Hello.
Yeah, good evening, sir.
Sir, you have told that DC motors is is not suitable for the electrical vehicle. Not suitable means there are the disadvantages in the traction
Yes, sir.
side.
Yes, sir.
How it will be if you are using the AC motors in the electrical vehicles? How we can overcome the starting problems, especially in induction motors, single phase induction motors or three phase induction motors? We are having many starting problems. How can we? It will be suitable for the electrical vehicles.
Sir, as we know, in case of single phase induction motors are not self-starting. For that, we are using some capacitor start like that.
Uh, Capacitor start motors.
Yeah,
While
because
driving, it may be the problem. I think so. In my concern, while driving the vehicle, when we are using the single phase or three phase induction motors, might
yeah.
be some problems. When that problem may be overcome by using DC motors. In the DC motors, these are the self started motors. I think
Yes, sir,
so.
those are self-started, but the drawback is here, as I told, brushes and commutation failure. Because whatever we are getting speed control T equal to K into pi in a DC missions, the same can be achieved in AC missions by using Clark and Park transformations. That means we are converting the ABC parameters to DQ. Indirectly, we are controlling the flux and torque with by controlling D and Q components. So similar control is possible in AC motors also. So that we are moving towards AC. In AC, because nowadays induction motors also used in some applications, PMS motors also used, BLDC motors also used, because there is some specific applications. There is some compromise. In each and everything, there is a drawback. In PMSM also there is a drawback. In BLDC also there is a drawback. In SRM also there is a drawback. But depends upon requirement, they will prefer the either induction motor, PMSM, BLDC, or SRM, switcher reluctance motors.
Okay, sir. In battery, when we are using the AC, there will be an charging problems. It will be there. I think so. Charging
Yeah.
problem.
Yes, sir.
Okay, sir.
Because
Thank you.
we are using battery management system, no, sir. The main problem is charging infrastructure. Now research due to lack of use of electric vehicle in India due to only lack of charging infrastructure. Now research is going on development of different fast charging structures, so that we need to provide the safe and control power supply to the vehicles. So we are using some battery management system. It will take care of these charging problems. According to the required power supply, it will give the control signal from to take the power from the charging stations.
Means we need to convert again to that AC to again we need to convert.
Yes, yes.
Like that we
Because
need
sir,
to.
yeah, in charging stations we are having two types. One is AC charger, one is the DC charger. Okay, in AC chargers we are having the onboard charger in the vehicle. It means that we are giving AC supply to the vehicle. In that vehicle, we are having onboard charger. It means AC is converted to DC. Again, DC is given to inverter. Inverter will drive the motor. In case of DC charging station, rectifier itself will be available in the charging station. So direct we will give the DC supply to the direct inverter. So there are two types of chargers: onboard and offboard charger.
Any more
Okay, sir.
questions?
Thank you, sir. Thank you.
Yeah. Okay. Thank you.
Any more questions? Thank you, sir. Thank you for your valuable information about hydroelectric power plant automation and the importance of RES and importance of is a solar system and importance of is a drives. Thank you, sir. Thank you for your accepting our request under your busy schedule, sir. Thank you, Dr. Pothuraju Ramakrishna Reddy, sir. Thank you, one and all.
Yeah, thank you, sir. Thank you for giving this opportunity. Thank you all for being your patience. And I think I have given some valuable information regarding more idea regarding electric drives, different speed control techniques, and importance of solar power in coming electric vehicles. And also there is a huge need of the need of artificial intelligence based control automation in hydroelectric power plant. Okay, thank you all.
Thank you, sir.
Yeah. Okay, sir, may I leave?
Okay, sir. Leave.
Yeah, okay, thank you.
So please leave the session, all the participants.